Hello everyone. So today we're going to be doing um, an, a problem with complex numbers. Namely, I'm going to show you how to convert a complex number from its algebraic form to its trigonometric form. So let's just go ahead and sketch our xy coordinate system. Okay, this is our y-axis, this is our x-axis. And now let's just go ahead, and this x-axis is actually our real axis in this case. Okay, so this is the real axis and this is the imaginary axis. And of course we can rewrite this as the negative square root of 3 over 2 minus 1 over 2 times I. So this of course is our real part of the imaginary number, and this here is of course our imaginary part of the complex number. Okay, so let's go ahead and present these two right here. So let's say that this here is negative root of 3 over 2. That's the real part. And let's say that this here is negative 1 over 2. Okay, so now we can go ahead and sketch it like this. So this is our complex number z in the complex plane. Now, if we connect these two right here, we can see that there's an angle right here. So it's oriented like this way, such that the cosine of that angle, is going to give us the real value of the complex number, and the sine is going to give us the imaginary value of that complex number. So first of all, what is the trigonometric form of a complex number? Well, it's simply the form okay, well, it's simply the form z is equal to r cosine theta plus I times r times sine theta. And from here, we get that this is r, this is the real part, and this is the imaginary part. So r is equal to, by the Pythagorean theorem, the real part of z squared plus the imaginary part of z also squared. So r is equal to, in this case, 3 over 4 plus 1 over 4, so r is just 1. And now what we have to ask ourselves next is, how do we get to theta? Well, theta from here can be seen as the arctangent of the imaginary part of z over the real part of z. So theta is the arctangent of the imaginary part of z is -1 over 2 over -3, -√3 over 2. So the minuses will cancel out, the 2's will cancel out. So that's the arctangent of the square root of 3 over 3 once you rationalize it. Now, since there are multiple angles, and it wouldn't really be correct if we wrote any of those angles. No. Why? Because we want to know in which quadrant of the complex plane our complex number is located at. Since both of its parts, both real and imaginary part, are negative, it's located in the third quadrant. So the angle, we're no longer asking ourselves what angle has the tangent of square root of 3 over 3. What we're asking ourselves is what angle is in the third quadrant and still has the square root of 3 over 3. So that angle is 7 pi over 6. So in other words, z is equal to cosine of 7 pi over 6 plus I times the sine of 7 pi over 6. And that is our final answer to this video. I hope you enjoyed it. If so, subscribe and leave a like. I'll see you in the next one, and goodbye.